Advancing the future with innovative cleaning solutions. Premium chemical. Innocence, a partner leading sustainable innovation. Here's the order of introduction. First, introducing Innocence technology. Second, premium chemical products. Third, refinery business case studies. Fourth, business direction. Innocence is a global leader in chemical removal of industrial contaminants. Innocence, located in Korea, possesses world-leading technology for chemically removing industrial scale generated during manufacturing processes. With extensive experience in oil refining, petrochemicals, power plants, automobiles, and electronics, Innocence already possesses technologies that meet the needs of these industries. We have been a long-time business partner supplying detergents to leading South Korean conglomerates, including SK Group, LG Group, Hyundai Group, and POSCO Group, as well as their affiliates. We also supply detergents to a wide range of industries, from oil refineries like SK Energy and S-Oil to petrochemicals, steel mills, power plants, and automotive. We also work with renowned European companies, such as Styrolution, Solvay, Valeo, Atlas Copco, Plastics Omnium, and BMW. We also supply detergents to neighboring Japanese companies like Mitsui Petrochemical and Toray Chemical. Innocence's core values are cost reduction, doubling the cleaning cycle, preventing safety accidents, and reducing carbon emissions. First, reduce operating costs through efficient cleaning. Second, increase productivity by extending maintenance intervals. Third, reduce the risk of accidents by improving the work environment. Fourth, realize a sustainable future through eco-friendly business. Energy savings are achieved by maximizing equipment efficiency without scale residue, and all mechanical equipment can be cleaned regardless of structural issues. By preemptively blocking factors that accelerate the aging of mechanical equipment, it can significantly improve productivity by reducing construction time by up to 70% compared to conventional cleaning methods. It can safely perform cleaning work even in narrow spaces or harsh environments, so there are no limitations to the workspace. Energy savings are achieved by maximizing equipment efficiency without scale residue, and all mechanical equipment can be cleaned regardless of structural issues. Premium chemicals offer exciting customer benefits. They save time and reduce costs by eliminating the need to disassemble complex, diverse machinery. Online cleaning saves time, and the elimination of consumable replacements significantly reduces costs. Introducing Premium Chemicals Representative Product Lineup. F15SK, a representative product of Premium Chemicals, removes malignant oil. A detergent specialized in removing high-strength scale and organic compounds, it provides a safe and powerful cleaning solution across the petrochemical, refining, steel, and automotive industries. It can completely remove coke, coal tar, and other substances that pose the greatest challenges in the oil refining, petrochemical, and steel industries by inducing a chemical reaction. F15SK detergent is a detergent that specializes in removing malignant scale, and is a powerful detergent that can remove unburned carbon, heat transfer oil, carbonized oil, hard oil, and complex organic substances. However, its excellent cleaning power does not cause damage to metals, and it can be applied to carbon steel, copper, aluminum, titanium, stainless steel, etc. Let's learn about the coal tar melting experiment sent from Asahi Kasei's Mizushima plant in Japan's petrochemical industry. Excellent dissolution properties have been demonstrated even with simple dipping, and the physical power of the circulation pump can be used during on-site construction to maximize cleaning quality. In the experiment, the F15SK detergent was heated to 60 degrees Celsius as a 100% solution, and the experiment was conducted using the dipping method through a beaker test for 1 hour. After dipping a 12G sample for approximately 20 minutes, the inside of the beaker became so turbid that it was impossible to see inside. However, after continuing the experiment for approximately 60 minutes, the 12G sample showed 100% complete dissolution, with no trace of fine particles remaining. Let's introduce a product line that is useful in refineries and crude oil extraction sites. The most significant challenges in this field are scale, including coal tar, coke, and limescale. Therefore, we will explore F15SK, which removes coal tar and coke, and F21C, which simultaneously removes limescale, organic matter, and inorganic matter from water. Let's illustrate with real-world examples. At China National Petroleum Corporation, CNPC, crude oil drilling sites, clogging of machinery is reportedly a serious problem due to several substances extracted during mining. The two most significant problems are coal tar and scale, which forms when groundwater reacts with crude oil. CNPC sent coal tar extracted from the mine site to Innocence to determine whether it could be dissolved through chemical reactions. I will share the results of a test. 1. Purpose: to simulate the conditions of crude oil extraction equipment and test the cleaning efficacy of F15SK on high-viscosity coal tar supplied by CNPC. 2. Information on the experimental specimen. Contaminants formed inside genetic equipment and are distributed throughout all genetic equipment. 3. Technical analysis. The active ingredient in F15SK effectively decomposes the aromatic polymer chains of coal tar, as commissioned by CNCC. Trace amounts of particulate residue were observed, and no hazardous gases were detected. 4. Recommendations. To maintain surface integrity, apply to a closed-loop circulation system and heat to 50 degrees Celsius to match the characteristics of the F15SK. As shown in the figure, a portion of the experimental specimen sent from CNPC is selected and immersed in a beaker containing diluted chemicals, and the 50 minutes until the end of the experiment are monitored in real time. The moment the test specimen is immersed inside the beaker, the coal tar reacts with the chemical and bubbles are generated. After about 20 minutes, the coal tar clumps began to break apart and the level of contamination inside the beaker began to increase. And after 50 minutes of experimentation, the coal tar has completely dissolved and the inside of the beaker is dyed black. Among the substances that cause clogging in machinery at oil drilling sites are barium sulfate and solids formed from the mixing of water and crude oil. Microorganisms can form biofilms inside pipes, which not only cause corrosion but also act as viscous substances, hindering fluid flow. Furthermore, the presence of moisture and oxygen inside equipment can lead to metal corrosion, accumulating in filters and valves and blocking the flow path. Now, let's learn about F21C, which can remove these substances. This example will be based on a limescale dissolution experiment commissioned by Kazakhstan and sent to us. This experiment was conducted to remove limescale solidifying inside a Kazakhstani boiler through a chemical reaction. F21C detergent is a detergent developed to remove coolant contaminants. In other words, it is designed to simultaneously remove both organic and inorganic scale. It is environmentally friendly and capable of simultaneously removing both organic and inorganic contaminants. It can be used in a variety of industries, including oil refining, petrochemicals, semiconductors, power plants, and shipbuilding. The test specimens were found to contain limescale solidified inside boilers in Kazakhstan, a problem that is so severe in Kazakhstan that physical high-pressure water washing cannot remove it. Dissolution tests were conducted with several research institutes and global chemical cleaning companies in Kazakhstan, but all failed. These test specimens were sent to Innocence for testing using premium chemical F21C. Here's a video showing the experimental specimen. The experimental specimen was dipped into a beaker containing diluted F21C detergent and dissolved for 30 minutes. The result was complete dissolution, with no fine particles remaining. Other products from Premium Chemical include Inno Remover 11 and RDS202, polymer-specific cleaners that dissolve a wide variety of polymer materials. F21C+, in particular, not only removes rust but also repairs iron oxide and heat discoloration caused by welding. Now, let's look at business cases in the oil refining industry. Trays are metal plates installed vertically in multiple layers inside a purification column, or distillation column, and are structures that help separate components by allowing liquid and gas to come into contact. Trays often become clogged or deposited with tar, coke, scale, salt, etc. during the process, so regular cleaning is required. If contamination is severe, the holes in the tray become clogged, obstructing gas flow and reducing separation efficiency. The top tray on the screen is the result of physical cleaning. The foreign matter trapped in the tray becomes fixed due to the high temperature, making it impossible to physically remove. This is the main reason for the shortened cleaning cycle. Therefore, to achieve better cleaning results, I soaked the filter in F15SK detergent before leaving work and washed it the next morning. The final results are as follows. A flame arrestor is a device that prevents flames from passing through machinery or pipes. It features a metal mesh or ribbon structure inside, absorbing heat as flames pass through, cooling the device below its combustion temperature. The photo on the left shows the flame arrestor before cleaning, while the photo on the right shows the final result after cleaning with Inno Remover 11. The chemical cleaning process shown in this video removes scale from a 1.5 km pipe. The primary scale components are silica and limestone, with silica accounting for approximately 85%. Contamination levels within the circulating tank can be monitored in real time. In other words, the scale within the pipe is dissolved and released into the circulating tank. Looking at the red graph for the pre-cleaning condition, the flow control threshold is 160 tons per hour. At a flow rate of 150 tons, the valve must be opened to a maximum of 105% to achieve the desired flow rate. This means the valve must be opened excessively to achieve control, indicating internal contamination or severe flow resistance. Let's examine the green graph for the post-cleaning condition. The flow control threshold is 160 tons per hour. At a flow rate of 160 tons, the valve only needs to be opened 75% to achieve sufficient control. This indicates that after cleaning, flow resistance has decreased, lowering the valve opening rate, demonstrating the effectiveness of the process improvement. Before cleaning, the valve had to be opened to 105% to achieve the desired flow rate, but after cleaning, the valve was opened to only 75% to achieve the same or higher flow rate. This suggests that the cleaning effect cleaned the flow path and improved the flow efficiency. Next, let's look at a case study of chemical cleaning for an air fin cooler. An air fin cooler is a device used to cool high-temperature fluids generated during the refining process. It is a type of heat exchanger that uses outside air to cool the high-temperature fluids generated during the refining process. This method removes heat by forcibly circulating outside air with a fan, without using water. Unlike cooling towers, this heat exchanger is more environmentally friendly because it doesn't use water, saving cooling water. The purpose of chemical cleaning of the air fin cooler is to remove scale and iron oxide adhered to the inside of the tube and to obtain an iris test to measure the thickness of the tube. The chemical cleaning process involves 1. Dilute the prepared cleaning agent with water. 2. Connect the air fin cooler to the circulation pump using a high-pressure hose. 3. Operate the circulation pump to inject the cleaning agent into the tube. 4. Operate the pump for a specified period of time to perform the circulating cleaning. 5. Once the process is complete, drain the cleaning agent from the air fin cooler for wastewater treatment. 6. Continue rinsing with clean water. 7. After drying, inspect the cleaning quality by selecting one of the following: temperature changes, flow rate changes, or visual inspection. The IRIS, Internal Rotary Inspection System, is an ultrasonic-based, non-destructive testing method used to precisely diagnose key equipment in refineries and petrochemical plants, such as heat exchanger tubes and steam generator tubes. The goal of this inspection goes beyond simple defect detection to maximize equipment safety, lifespan, and operational efficiency. The primary objectives of IRIS inspections are: 1. Detecting internal pipe defects, 2. Predicting equipment life, 3. Preventive maintenance and accident prevention, 4. Improving operational efficiency, and 5. Supporting data-driven decision-making. The image at the top of the screen shows the graph before cleaning. The graph displayed on the monitor shows a shaky curve. However, the image below shows the graph after cleaning, showing a straight line without any shaky or curved lines. This analysis shows a perfect cleaning result. The previous explanation covered the internal cleaning of air fin coolers. Now, let's look at chemical cleaning for the external cleaning of air fin coolers. The purpose of external cleaning of air fin coolers is to remove dust, rust, oil particles, resin, and other contaminants that accumulate between the fins, impeding airflow and reducing heat transfer. Looking at the before and after images below, the aluminum fins are coated with foreign matter, making them undetectable to the naked eye. The gaps between the fins are completely blocked. However, after chemical cleaning, the fins are clearly visible, revealing the excellent quality of the chemical cleaning. Considering the difficulty of removing dust, oil particles, rust, and other debris from the aluminum fins without damaging them, these results clearly demonstrate the premium value of premium chemicals. Now, let's examine the performance data for the external chemical cleaning of the air fin cooler. The E105 air fin cooler had accumulated contaminants on its fin surface due to long-term operation, reducing heat transfer efficiency. Therefore, external cleaning was performed, and the performance improvement was analyzed based on temperature data before and after cleaning. After cleaning, the maximum temperature decreased by an average of approximately 14.84 degrees Celsius, indicating a significant improvement in heat transfer performance. Bank 6 had the largest delta T of -20.31 degrees Celsius, indicating that this bank had the highest contamination level. Conversely, Bank 2 showed relatively little improvement, suggesting less contamination or a limited cleaning effect. The temperature of the D103 accumulator also decreased by approximately 10 degrees Celsius, indicating that the cleaning had a positive impact on surrounding equipment. The following illustrates a case study of chemical cleaning for a shell and tube heat exchanger in a refinery's CDU process. Crude is carbonized and adhered to the shell side, while coke is carbonized and adhered to the tube side. This video demonstrates the simultaneous removal of carbonized crude and coke from both the shell side and the tube side by chemical reaction. This is a case study from a refinery in Korea that also operates a petrochemical plant. The project targets heat exchangers where butadiene is stuck between the tubes on the shell side of the shell and tube. 3 shell and tube units were scrapped and stored in a waste disposal facility. This project aims to chemically remove the butadiene stuck between the tubes of the 3 scrapped heat exchangers, allowing them to be reused. Also, we will introduce a method of cleaning by immersion in a tank rather than the previously introduced circulating cleaning using a pump. The tube length is 5,000 mm, and there are 2,717 tubes. This is a highly challenging task, requiring the removal of butadiene of a thickness and length equal to the diameter of the bundle. Half of the bundle is immersed in the tank, sealed, and stored for 7 days until the butadiene scale dissolves. Once cleaning is complete, the bundle is rotated and placed back into the tank to immerse the remaining half. The tank is then sealed again and stored for 7 days to complete the chemical cleaning. Finally, to check the cleaning status of the heat exchanger, a pressure washer is sprayed between the tubes and the high-pressure water is discharged from the opposite side. This indicates that the butadiene, which was tightly trapped between the tubes, has been completely removed. If you want to check the washing status in real time, you can install pressure gauges at the inlet and outlet of the target equipment and check the washing status in real time through pressure drop or pressure. The next business case we'll cover is a seal cooler, which protects and cools the seals of pump motors used in refineries when they rotate. When a seal rotates, temperatures can reach localized temperatures exceeding 300 degrees Celsius. The device that cools these seals is called a seal cooler. Calcium solidifies in the gaps between the tube coils of the seal cooler, forming a rock-like hardness. It's so hard that it can't be broken even with a hammer. This rock-hard scale can be easily removed through chemical cleaning, while the seal cooler is connected to the pipes. Now, let's explore performance data after chemical cleaning with premium chemicals. Performance data is a formal verification process for cleaning quality through quantitative data. Quantitative data can be verified through 3 factors: temperature changes, flow rate changes, and visual inspection. The graph displayed on the screen is excellent data provided by the customer, representing real-time temperature measurements in the monitoring room. During operation, the heat exchanger's cooling water temperature reached 88 degrees Celsius. Chemical cleaning using the existing detergent lowered the temperature from 88 degrees Celsius to 38.6 degrees Celsius. However, after 2.5 months, the temperature rose again to 82 degrees Celsius, causing fouling. Innocent's premium chemical detergent was used instead of the existing detergent. This resulted in a cooling water temperature drop from 82 degrees Celsius to 33.2 degrees Celsius. The cleaning cycle was extended from 2.5 months to 9 months. Now, 8 years later, the cleaning cycle is reduced to once a year, significantly reducing costs. This is a prime example of this. Finally, I'll present a business case study comparing our technology with that of global companies in the same industry. To remove contaminants from the inside of shell and tube heat exchangers, global companies conduct chemical cleaning in rotation once a year. However, the contaminants inside the heat exchangers were never removed, and because cleaning was not possible, iris testing was not properly conducted. However, as you can see in the video, after chemical cleaning using premium chemicals, the contaminants inside the tubes were completely removed, and the tubes gleamed like new. The image at the top of the screen shows the graph before cleaning. The graph displayed on the monitor shows a shaky curve. However, the image below shows the graph after cleaning, showing a straight line without any shaky or curved lines. This analysis shows a perfect cleaning result. If you would like to send Innocence a test sample for lab testing, please collect a handful of test samples from the target equipment and send them via DHL, as shown in the image on the left. Innocence will complete the lab test and send a test report via email. Upon request, we will also send the samples used in the test.